So this is going to be the first episode of the Gen 2 podcast. I don't have a co-host yet. I don't know anyone who can do it. I'm just going to go through some tech news. This is going to not pertain to any particular subject. Going to go across hardware, software, maybe a little security. And this isn't going to have a set length. I'm just going to do it until I get through these stories that I have. I don't have too many of them. So let's get started. And this first one, it's going to be a little clickbaity. Got a little bit of attention from the media. Don't turn off the stream immediately when you see it. We'll get past it. So, in Britain, electronics student, elementary school, kid makes homemade clock, takes it to school, they think it's a bomb, police are called. After the electronics teacher says, no, it's a clock, and then everyone gets mad, but not because of the outrage of thinking an electronics project is a bomb, but because he's Middle Eastern, and, you know, if he's Middle Eastern and you think he has a bomb, it must be because the police are racist. So, I mean, if you look at this, and you know electronics, you can see, like, they got a transformer here, got a place for a 9-volt battery, display, and this looks like a hand-soldered board. Looks like it wasn't even etched, like he scratched it and then filled it in with solder or something. But I mean, most people aren't going to know what this is, so they just freaked out, obviously. And, you know, they must be racist. The thing is, though, there's this kind of culture developing in Britain. Police called after 9-year-old uses a ruler as a pretend sword in a game of Knights and Dragons, and the police are called. It's not a racist thing in Britain. It's just, you know, their elementary schools are really, dumb. They, you know, someone was playing pretend sword with a ruler, so we gotta call the police. There's also another story you can look up of a kid bit their Pop-Tart into the shape of a gun and police were called. Because, you know, he might shoot someone with that. Anyways, let's move on to something real. So this is the Smok Zero. It's a portable x86 Steam machine for $300. Let me just get out my notes. So this is a portable x86 architecture Linux box. It has an AMD G series system on a chip using a Jaguar CPU GCN based graphics, 4 gigs of RAM, 32 gigs of internal storage, plus an SD card slot, which will be good. OTG, so you can plug in more stuff. 5-inch 720p touchscreen. Has trackpad style joysticks like on the original Steam Beta controller. HDMI output, Wi-Fi, Bluetooth, and 4G on the Pro version. So first up, it's x86. I was thinking something like this. If they used ARM, they would want to go with a distro that compiles from source, because then any game you run on it would just be compiled for that architecture, but that's not happening. Games are going to be binaries. They're not going to distribute the source code. That's not for a while. 4 gigs of RAM, good amount of RAM. That's decent. A lot of phones today have 4 gigs of RAM, but they use it in a very different way from a general use computer. 32 gigs of storage, not very much. I mean, but this probably isn't going to be used for AAA titles maxed out. You can have maybe one of those games, and you can run it on medium or low settings. I believe this was a 9-watt TDP chip. So most typical ARM-based system of chips. Okay, they run from 6 to 25 watts. I have an AMD APU laptop where the CPU runs at 5 watts, and it's a pile of dicks. I mean, the processor maxes out very quickly. It can barely run Half-Life 2, but they might have gotten better. USB on the go. That'll be neat, I guess, if you want to play with friends, I guess. I never really got that whole thing. 5-inch 720p touchscreen. So touchscreen, very nice. 720p, not so nice. What I think they're doing here is they're kind of taking the Nintendo route if you look at like the 3DS, it has a super low resolution screen because then it doesn't take much GPU horsepower to drive that screen. And even then, they strip down the graphics pretty much. I mean, you compare the Wii U Smash 4 to the 3DS version, and 3DS is like Paper Mario status. The trackpad joysticks, I haven't used trackpad style joysticks. I have only used 360 controllers, GameCube controllers, PS3, PS4, PS2. I don't know how well they work. They must work well for them to have gone with them, though, and have Valve to have had them as an option on their controllers. HDMI output, you're likely going to be able to output 1080p video, but that's going to hurt your performance a lot. I never really got hooking this up to like hooking a portable console up to a TV and then playing it on the TV. That just doesn't really make sense to me. I do get the reverse, like the Wii U, where you can have the console on, someone using the TV, and then you can play like a Game Boy game just on the controller and just go into another room and play the game on the controller. But that's the opposite of this. Wi-Fi, that's a must. I mean, can't get along without Wi-Fi. Bluetooth, I don't really care. Maybe have a headset. And then 4G, if you live in a heavily populated area, this will work for you. If you live anywhere else, this is kind of pointless. I even live in a moderately populated area, and 4G signal is just garbage. Like, anywhere I am. I'm not going to be able to play games over 4G. I'm certainly not going to be able to download with the data caps that are in place. Some people might use it. I'm definitely not going to. Would I get one of these? Maybe. $300, that's not too bad. If this was like $400 or $500, I definitely wouldn't. $300 is decent. Throw some emulators on there. NES, SNES, 64. Maybe a few GameCube games, like possibly Melee. Maybe if you're really lucky, because I know that runs on ARM phones right now. Melee runs full speed just fine on some Android phones. It might run on this, maybe, if you're lucky. Because I have had some portable gaming consoles. I had a PSP, and I didn't play PSP games on it. I just got a custom firmware and played emulators. Probably the same thing here. Next up, Skylake. Possibly to have reverse hyperthreading. This is probably bullshit by now. This is the rumor mill. Unless one of their newer CPUs they release has this that they haven't told us about, then nope. This is something that I would like to see implemented eventually, though, because we are getting to the point where we have a lot of threads on a processor and a lot of cores, and most application developers aren't threading their applications properly, because most applications don't need that, and the few that really do need it, even then aren't. A perfect example, it's a game called Prison Architect. It takes its roots from Dwarf Fortress, and it doesn't thread properly. It has a main thread and it has helper threads. So on my processor, 2500K, I can get to about 900 prisoners, and then my FPS drops below 20 FPS, and it's completely unplayable. Just completely because the CPU and that one thread does not run fast enough. So I wanted to actually do a comparison, because Skylake just came out, and every time a new processor comes out, everyone's like, oh my god, new processor, this is great. So I wanted to compare 2500K to a 6600K, and this is very loose benchmarking. Obviously, if you get into the more complex benchmarks, there are some things that one processor is way better at that make a huge difference. But this is more of a general use case. If you're, say, gaming, or you're, say, well, you probably wouldn't have an i5 if you were web browsing. If you don't care about looking up the specific benchmarks that comparing these processors, they probably don't matter. And I was doing some spitballing numbers between these two. 2500K can overclock a lot better than the later chips in the series. And when you overclock these to their max, you're still seeing an under 10% difference in performance. One benefit of the newer ones is you're going to get lower TDP in general, and you're going to get way better integrated graphics. DDR3, DDR4 support doesn't really matter yet. DDR4 doesn't provide that much of a benefit. So you can see 32 nanometers versus 14. Really, 91 watts? I thought they were in the 70s. That's terrible. But they have some benchmarks here. So, yeah, 34% better in Cinebench single core. Multi-core, you're seeing a 17% difference. And then integrated graphics card. This is one of the big things. You're seeing a 50% difference. A single core, 23%. Multi-core, 23%. Passmark, 23%. Again, 24%. You're not seeing a huge difference. Any difference is going to be under 25%. And for me, that's not something I would do. If I was building a system where I had to use integrated graphics, I'd probably go with an APU anyways, but if I was going to go Intel, I'd definitely go with the 6600K. This just doesn't justify the price difference for me, though. If this was like a 50% increase in performance, that's worth it, but 25, not really. If the TDP was insanely low, I would go for it, which is actually why I'm upgrading to a processor with half the TDP of my current processor and getting better performance. That's why I'm doing the upgrade. Something like this, not really worth it. So next up, Firefox is integrating ads to the new tab screen. So this is called suggested tiles. That's a great euphemism. Suggested tiles is an advertising experience that delivers content recommendations that are relevant to the user in a transparent way, while at the same time respecting their privacy and giving them complete control over the experience. Does that mean we can disable it? Just something I want to know. They want to obviously boost their revenue because they're losing browser market share. And they say it respects your privacy, but it's based on your browsing habits. So they're going to be indexing your browsing habits. I'm wondering what ways are they going to keep your privacy secure while indexing your browsing habits? Because what if, and I'm putting on my tinfoil hat here. I don't have a physical one yet, but I will. What if the NSA says, hey, Firefox, or Mozilla, you're a US-based company. How about sending us those usage habits? They probably won't, but it's a possibility in tinfoil, etc. But yeah, integrated ads, not fun. So this is something that's a little older. August 13th, like the one that was defunct. 2.5-inch, 16 terabyte SSD. This is using their new VNAND technology. So the original SSDs that were super expensive and not worth it, they used SLC, which is single layered cells. This means you would get 1 bit of storage per cell. Then they introduced MLC, which was 2 bits per cell, or 3 bits per cell, which was TLC. Very recently, they're having quad layer, which is 4 bits per cell. Now, the more bits per cell you add, the slower it gets, but you're still going to have way faster speed in every aspect compared to a mechanical hard drive. Now, when you add more bits per cell, this also lets you increase the storage of the drive while decreasing the total cost. So, instead of having, let's say, two 256 1-bit per cell drives, which would cost about twice as much as having a single 2-bit per cell 512 gig SSD. Anyways, Samsung's new VNAND technology, they can stack up to 48 layers of these cells per chip. That is a insane amount. It's way more than anything that has been done before. So they announced a 15.36 terabyte SSD, and it is thicker than a standard 2.5-inch drive. You're not going to be able to stick this in the laptop. I don't know why you would, because it costs about $7,000. They speculate $8,000, $7,000 if you're really generous. This is obviously enterprise only, but what you're going to see is this is going to come out, and its price is going to drop exponentially, because that's what happens. Technology doesn't improve from new stuff being invented and people buying it. It improves from new stuff that's been invented a few years ago becoming cheap and affordable, like SSDs. You look at something like this, they don't have any graphs of it, but the amount of storage of SSDs is increasing exponentially because it's becoming far cheaper to produce this technology. It was like a year ago when SSDs were, they were kind of economical, like, okay, it's kind of worth it now to get a SSD boot drive and an OS main drive. When they first came out, it wasn't. You could have bought a whole RAID array for the price of a single SSD. Now it's getting to the point where for a medium to medium high budget, you can have a completely solid state system. And you would still have to manage data a lot more than a hard drive. But again, that would be at the cost of the performance of an SSD. So currently, the largest hard drives are 8, 10, and 12 terabytes. If you compare this to a solid state drive, you're going to run into a lot of problems. For those of you who don't know, a mechanical hard drive works a lot like a CD drive. It spins the platter, and it has to move this head back and forth and read and write from the right locations. So you can really only access one spot at a time. You have to wait for it to get into position, all this kind of stuff. With SSDs, you can access anywhere on the drive instantly, and you can access multiple places at the same time. So this technology here, this 16 terabyte SSD, this is going to dramatically decrease the cost of consumer SSDs, which again are already affordable at reasonable costs. Right now you can get a 1 terabyte SSD for about $350, and that's a lot if you're making a budget system, but if you're shelling out money on your computer and you care, or you're in a production environment, that's completely affordable. This is still pretty bad price to storage ratio compared to a 4 terabyte hard drive. You can get that for about $150. That again doesn't have the benefits of a solid state drive, but this technology is only going to become cheaper. So next up, IBM has built a digital rat brain that could power tomorrow's smartphones. Probably not. This is a technology that simulates neurons with circuitry. So this has, 48 million digital neurons, which is roughly the same amount in the brain of a rat. I did a skimming of their language specification. It's called Corlet. I'll just open it up here. And it's very interesting. They go over why they made it, how they made it. So this is like a basic structure. You have inputs and outputs, and all of these interact together. You have 48 million of them, and it's very interesting because when you write a program, it's not like an imperative program today. If you wrote a program in C++ or Java or Python, you're telling it what to do every single step of the way. Do this, do this, do this, do this. If this happens, do this. If this happens, do this. It is, declarative. You are declaring what to do for every single case. Now, if you look at imperative languages, which is a completely different paradigm, let's say Lisp, everything is imperative. You're telling it how to do things. This took a while for me to understand, and the best way to do it is to just learn the Lisp language. MIT has free lectures on YouTube if you want to learn it. It is a little deep, but very clear. One of the things imperative systems are really, really, really good at is self-modifying programs. And this is something that you see in these neuron programs. So you write a program, and the way it changes itself is by self-modifying. With imperative programs, they're very good at that. This is just a parallel I noticed between the two. It's very interesting, and this has a lot of applications, especially probably in neural networks if you were to link multiple of these together, because you're going to get that hardware acceleration. Anyways, so back to storage. 100 terabyte hard drive, about 2025. These are different technologies that exist. So this is what we have now. It's pretty much the same as a CD drive, but instead of optical, it's magnetic. There's this new technology called Hammer, which exists in the lab. It's not out for production yet. They pretty much use, instead of a small magnet to change the bits from zeros to ones and ones to zeros, they use heat to do it. Heat is assisting it, which lets you get better data density, and then you get heated dot magnetic recording, which is entirely heat. It's just using heat to change the magnetic properties of the medium. And it's funny because, again, when you do this, you also get more sensitive equipment, so don't put any magnets near these drives. They're saying about 2025, and if you look at 16 terabytes now, this is a lot more expandable. So let's say I want 100 terabytes, so you get 6 of these, and that costs you about 50 grand. That's a lot of money, but you're getting 100 terabytes of SSD grade performance today, right now. If you get this, let's say this is $100, but you're having to wait till 2025, and you're still running into the same problems of mechanical disk drives, which is limited read spots per second. You have to wait for the data to pass over the head, and it's more likely to have a mechanical failure. There are some ways you can improve this, like multiple heads reading and writing from the same platter at the same time, but you're still not going to get nearly the same performance. I don't think hard drives are going to go away as a technology, but in the consumer market, they're going to completely go away. In the enterprise market, for the most part, they're going to go away. There's still going to be a use for them, but it's going to be heavily scaled back. No, we already went over this. Firefox advertising. This is something interesting. It's called zero latency, and it is VR. So they pretty much have a giant warehouse mapped to a giant virtual environment, and what you do is you put on a mini ITX. I'll look it up. You put on a Alienware mini ITX computer. You have what looks like PlayStation, PS4 motion tracking on your head and gun. And it is a giant campaign. Co-op, 4 to 6 players. It costs $65 per person. They have an Oculus development kit too. You wear earphones. This is what the world looks like. Decent graphics. I like it. You obviously don't want to run into other players, but you can see where other players are, so you're gonna know not to do under that. You definitely don't want to trip, because that would be a very expensive trip. And there's no cords on this, which is really neat. These are probably extremely, extremely, extremely low power systems, and then they just have a battery on them with that small computer. And it's $65. That would that that seems reasonable. I would want to do it with some friends for sure. But it's in Australia. I'm not going to fly to Australia all the way to do this. The graphics look decent. It's all right. I would like to see this appear in America, be something maybe as a replacement for laser tag. I would like it even more if it wasn't just a flat world. If they actually built a real world, mapped it to a virtual world, and then you could like run up and like lean against a virtual wall, and there would be a real wall there. And let's say it's drywall, they would make it a real drywall wall, so you feel drywall, and you get to the point where your brain is fully thinking that the game, the 3D model body, is your real body. That'd just be really neat. So this is something that's caused some internet drama. AMD has seen a huge performance increase from DirectX 12. NVIDIA has seen about the same or worse. So people have said this is because of asynchronous computing, and I'm going to just put my little hypothesis out there on what I think it is. So AMD has always been better at NVIDIA at raw compute power. If you wanted to, say, mine bitcoins, which is something that's pointless now, you would get AMD graphics cards. If you want to do video editing, you would do AMD graphics cards, unless you want to do real video editing, because only Apple has support for AMD graphics cards. If you wanted to build a supercomputer, you would want to use AMD graphics cards. Though that's debatable now. One of the big reasons is because AMD has huge amounts of just raw computing power compared to NVIDIA. About 40% better raw compute power. One thing NVIDIA has always been better than AMD at is gaming performance. Their drivers will have crazy performance increases. Like when Crysis 3 first dropped, you would see like a patch that's 30% performance increase because NVIDIA optimizes per game for their drivers. AMD's been the underdog. They haven't had the money to really put into optimizing their drivers per game. Now, when AMD made Mantle, this was something that was really neat because DirectX 9, 10, and 11, and OpenGL, they really didn't let programs access the graphics cards very much. Drivers were kind of like a giant dam of control, and they were only letting you control very little bits of it. So what AMD did was they made Mantle. This allowed you really low-level control of the graphics card, which gets you way better performance. Drivers matter a lot less with this, and they made it open source. So what happened was Microsoft was like, hey, that's great. We're going to take large parts of this and make DirectX 12, which is great because performance increase. And then Vulkan, the replacement for OpenGL, was like, hey, we're going to take this because that's great. And then Mantle died because it was AMD only. I mean, there's no reason for them to bring it to NVIDIA. And then DirectX 12 is going to be on all cards, and Vulkan's going to be on all cards. It was the martyr for the next generation in graphics APIs. But because it, and one example of it allowing you to see the raw performance of these cards is if you compare SLI. Let's say, and it doesn't matter, SLI between NVIDIA cards, Crossfire between AMD cards. This is using two graphics cards on one computer to play a game. What happens is, instead of combining the processing power of both the cards, you are having graphics card A render frame A, then graphics cards B render B frame, then A, then B, then A, then B, then A, then B, and you're just alternating cards. So you can hypothetically run twice as intense graphics, but because it takes each card twice as long to render each frame, but because you have two cards, it about equals out. The problem is not all graphics cards are equal, so they will get out of sync very easily, and you get what's called micro-stuttering, where instead of running 1 2 1 2 1 2 1 2, it'll be 1 2 1 2 1 2 1 2, and you'll have these big gaps and then two really quick frames, and it's just really messy. What DirectX 12 and Vulkan allow you to do is it allows graphics cards to work together to render each individual frame. So something like micro stuttering will no longer be a problem ever, because that's not how it works. You're allowing the game to leverage the raw processing power of the graphics card. So you look at these benchmarks, and you look at DirectX 11 and 12 on like the 980, and yeah, it's about the same more or less. You see performance decrease, whatever. You look at AMD, and woo, huge increases. I mean, 47 to 74, 48 to 81, 38 to 48. And this is because once you get above 26 graphics processing threads on NVIDIA hardware, it just kind of shits itself, and it can't take it. It just can't. Now, asynchronous computing is what this is called. The reason I think AMD is so much better at this is because they just have so much more processing power. You're not really running into that thread limit. There is a thread limit on AMD cards also, where you throw enough threads and then it's just going to shit itself, and you're going to get the same thing. With NVIDIA, what they're doing is they're using fewer cores, but they're doubling the performance of each core, which makes this thread count, once you hit this thread count and it starts shitting itself, that's going to be a lot lower. And I looked it up. I don't have the numbers right now, but you compare comparably performance AMD versus NVIDIA card, and then you compare the raw number of cores, and AMD has about 40 to 50% more cores on their cards, and it's just a parallel with these benchmarks you're seeing where they have these 40 to 50% performance increases. Now, NVIDIA, of course, is going to fix this. They're likely going to have a software patch that fixes it. It's not going to be as good as an actual hardware patch. Not something you can really do very easily. Just ship all the consumers kits to etch their dyes again. Some small vapor deposition chambers. It'll be great. They'll fix it. NVIDIA users won't have to worry at all. But on the next generation of cards, this will something that'll definitely be addressed. They'll have to implement better asynchronous computing, even though they have fewer cores. That strategy kind of worked against them, doing fewer cores with better performance versus AMD. But I think you're going to see drivers mattering a lot less in the coming years, because the games are taking advantage of the cards, and drivers are far less involved with this. It's going to get to the point where the only time you're going to need to really modify drivers is we have this brand new game and it uses this brand new feature in a very specific way that super relies on it, so we need to optimize it as much as possible. Or we're making a supercomputer and we need to optimize this one feature as much as possible. You're not going to see any real game-based performance increases. It's going to work for most games for a while. I mean, you're still going to see updates, and they're always going to be optimizing. But you're not going to see, we released a patch that improves performance 30 to 40% in this one game. It's going to be, we released a patch, and it's a 2% performance increase. Next up, Intel is supporting FreeSync with their future integrated graphics cards. So, G-Sync versus FreeSync, they've been out for a while now. G-Sync is NVIDIA's dynamic refresh rate. FreeSync is AMD's dynamic refresh rate. And long story short, AMD is going to win this. G-Sync was NVIDIA only. If you wanted to use it, you would have to buy a monitor with G-Sync in it. It had a special board inside the monitor that would talk to your graphics card to make G-Sync happen. G-Sync does have a feature that FreeSync doesn't. But achieving the goal of dynamic refresh rate, this makes it die. So what is dynamic refresh rate? Your screen refreshes 60 times a second. It goes, if you imagine them as a grid, it goes from the first row left to right, then it goes down to the next row left to right, down to the next row left to right. It does this 60 times a second, and let's say your graphics card is producing a video game, and it's running at 60 frames a second. It's not producing 60 frames exactly at the same intervals 60 times a second. There's a little offset between these frames. So it'll look smooth, and the more frames you get, so compared to like 144 hertz panel, it's going to look smoother. But if you are able to dynamically start the refreshing of frames at the specific times it receives the frame, so if it gets this frame a little earlier than the next frame was made, or a little later than the last one, you're going to get better. It's going to look a lot smoother, even though you're holding that frame for a little longer or a little shorter. Since NVIDIA has added this extra feature, which is frame interpolation, it makes it a better product overall. But as far as dynamic refresh rates, you're just putting more strain on manufacturers and slightly more cost on the consumer, because you are going to have to integrate these modules in mass production. It's not going to be very much. I would say like a few dollars max. But it's something they have to deal with. So what is frame interpolation? There are programs to this Smooth Video project, which is going to die because it's becoming paid. Let's say you have a 30 FPS video. It can make it appear to be 60 frames a second. So with G-Sync, if you're running a game, it works from 30 to 60 FPS, and if you fall below 30 FPS, it starts interpolating frames so that you get about 30 FPS. It's not as good as actually generating 30 frames, but it looks good enough depending on who you are and if you care that much. Huh? Phone vibrated? Oh, I think it's dying. Anyways, FreeSync. So, this was made by AMD. They actually integrated it into the DisplayPort standard, which is also a lot more open. It requires 0 extra hardware. Some monitors, it actually works by just updating the firmware of the monitor, because DisplayPort has some extra pins you can use to send data. So once they made the standard, it was possible to just update some displays to listen on those pins and dynamically start refreshing in the next frame when you get those signals. It has no interpolation features. This is the thing that makes it worse as a consumer item, but better for manufacturers, because it costs them nothing to do it. You ask the software engineer, hey, listen on these pins on DisplayPort for dynamic refresh rate, and there you go, it's integrated. That's all they have to do. If they want to use, like, say, G-Sync, they have to buy this module, they have to place it, they have to hook it up right, all this kind of stuff. So Intel is supporting this because it is an open standard. And I don't mean that in the open source way. I'm not sure if it is. But anyone can participate with this. It's integrated into the DisplayPort standard. If you want to get G-Sync, you have to go through NVIDIA. You have to talk to NVIDIA. NVIDIA is the arbiter of G-Sync. If they don't like your product, they don't have to give it to you. But FreeSync, they don't care. Integrate it. FreeSync for everybody. NVIDIA would likely have, specific things they want you to do. Like, if you wanted to make an open source version of your monitor, they're not going to tell you what's in that. They would be against something like that, because then people would replicate it. But anyways, Intel is going with it because of that open standard. They can integrate it on their end, and it doesn't take anything extra. If they wanted to integrate G-Sync, they would have to partner with NVIDIA, and they would have to integrate an NVIDIA chip inside of their processor, and it's giving NVIDIA power over something that they don't have to, because if they just go with FreeSync, it works, and they don't even have to get involved. That's all I've got for stories today, so if you would like me to cover more stories, please send me a message on YouTube. I actually read those. Comment below. Like it if you liked it, dislike it if you dislike it, and please comment why if you disliked it. I will be getting a camera soon. Subscribe for more podcasts, and I'll see you guys later.